All right. Welcome, welcome. Okay, this is the second part of your transformations of quadratic functions. So yesterday we talked a little bit about this. We had it like f of x, okay, same thing as y is equal to a times x minus h to the power of 2 plus k. And so just a little bit of a review. K was what type of movement, what type of transformation? It's up or down, otherwise known as vertical translation. Okay. And then of course that makes H. Let me talk to Isai. What is H?
Left or right.
Left or right. And so instead of vertical, we might refer to that as horizontal translation, right? Very good, sir. All right, who remembers what A? We didn't get into it, but we kind of mentioned briefly. It should be in your notes. A is all about, at least the absolute value of A is what we call dilation. Okay, and that's what we're really going to be focused on today. That's where things go. They stay the same shape, right? But maybe you start off really small and you get really big, or you get really big and you start off small, right? But it doesn't change shape, it just changes size. So when we look at 4a, we're going to describe this graph as it's related to this. Now, one last thing, especially on the homework assignment. What is the name of this right here? Talk to Ariel. What is the name of this equation right here? Thank you. Starts with a P. Oh, and if you, oh, good guess. If you weren't here yesterday, it might be a tough question. It's actually a parent quadratic. Okay, so that's the parent quadratic function. And please note on your test, they're not going to always say like, how does it relate to y equals x squared? They're actually just going to say, how does it relate to the parent function, right? And they do expect for you to know what that means, right? They expect that you know that that's y equals x squared. All right, so let's go ahead and let's take a look at this. A in this sense right here, the value for A is whatever's in front, right, is 1/3. And the absolute value basically just strips away any signs. If it's positive or negative, it doesn't matter. It just makes it positive. So same thing, the absolute value of A is 1/3, okay? So what we're gonna do, let's go to our calculator. We're gonna type in x squared, and the squared is right here. That's our parent quadratic. That's what we want to compare it to. That's the one that goes right through the origin like we talked about yesterday, right? Then I'm going to toss in under y2 my second one. So to put in a fraction, that's alpha y equals 1, right? 1/3 to the power of x and squared. And so then I'm going to go ahead here and I'm going to talk, I'm going to go to my graph to see kind of what happened. And it's kind of hard to tell like which one was which. Let's look at, so when I do this, that's the only thing. The other calculator, it had color. Let's see if we can kind of figure this out. Let's go to our table. Sometimes the graph is helpful and sometimes not so much. So I know this one is my parent, right? And I'm going to go ahead and I'm going to sketch it. I don't know what happened to my little graph. I used to have a little graph right here. I'm going to go ahead and sketch it right here. And we're going to make it kind of, you know what, we're just going to go up by ones and keep it simple today. Okay. So we know that our first point here is 0, 0. I've got 1, 1, 2, and 4. So that's 3, and I like 4. And I think that's enough. Okay. Now, due to symmetry, I can kind of, because I know, like, look, see right there? I got the 1, negative 1, 1. And then again, I got the 4, right? So I go like this. I thought that was like a fire drill or something. And we have something like this, right? And so I know according to my graph, the second one started at the same point, right? Had the same vertex, so it didn't shift to the left or to the right or up or down. But let me kind of compare these points. So now I'm looking at one being at 1/3. So that's like lower, right? And then I'm just going to kind of skip ahead to 3 and 3. So that's 1, 2, 3, 1, 2, 3, something like that. And I'm going to use symmetry. And then just kind of sketch. So this is just a rough sketch. So how would you describe the change? If we start off here, this one is the one that has 1/3 x squared. And this is our original parent quadratic. What kind of changes would you describe? Go ahead and put something in the chat. All right, this is what we call, it gets, for those of you who said it got larger, it got wider, right? That it widened. Yeah, that's a pretty accurate description. What we call that is vertical compression. And I don't know why I think about it like this, but you know, like SpongeBob, right? Okay, this is gonna be my impression of him. Like this is what he looks like normally, right? It's like incredible drawing skills right here. Okay, now that's him normally, right? But with vertical compression, that's where you have like forces pushing down and pushing up, right? And what do you think is going to happen to a little SpongeBob? There's his little feet. He's going to squish. He's going to get shorter. And he's going to get wider, right? There he is. You see him? And so this, that's kind of what's happening here. It's getting wider, right? So shorter and wider. And that's what vertical compression is. Okay, that's what happens. It's like if we take that gray parabola and squish down on it, right? And just make it shorter and fatter. You can tell it didn't have a translation because the vertex is in the same place, right? But that's what's happening here. So here we have 1/3. We know that, and then over here, we have 2 for A, right? So the absolute value of A here is going to be 2. Okay, so they threw in the 1, all right. The general rule for vertical compression and vertical stretch, because that's the other one, vertical stretch. Vertical compression is if you have a value for A, the absolute value for A is less than 1, okay? So if it's a value less than 1, it's going to be vertical compression, okay? It's going to push down, it's going to become short and wide, okay? Vertical stretch, which is what we're going to have here. I'm going to go to my calculator to help with this, okay? We're going to draw our basic parent quadratic. So that doesn't change. We have 1, 1, and we have 2 and 4, something like that, right? So I'm going to use, that's our parent quadratic. And I'm going to go over here and I'm going to type in the new one, clear. And I have 2x squared plus 1. And I'm going to look at my table. So I'm like looking at this value. I've got at -2, I've got 9. That's a little bit high. I've got -1, I have 3. So I'm going to go ahead and write that in. At -1, I have 3. 1, 2, 3. Boom. Okay. At 0, we have 1. At 1, I have 3. And so I'm looking at something like this. As compared to our original parent quadratic that look like this. All right, because we've got 2 numbers in here, we had 2 transformations that occurred. Okay, not the best parabola, but you get the idea, okay? One of them was from the 2 in the front. This is our vertical stretch. Notice how it got more narrow, yes? And so my little SpongeBob example again, this is where we have pressure, like he's basically being stretched. Like somebody grabbed a hold of his head and his feet, right? And we're pulling away. And this is what happened to SpongeBob, for those SpongeBob. Okay, and he got all tall and skinny. Yes, that's vertical stretch. And so it becomes longer and thinner. I'm going to say tall and thin. But you do have to know the term vertical stretch because that's what's going to be on your chest. Vertical stretch is what's happening here. So that's one transformation due to the fact that the absolute value of A is 2. And the general rule is that if the absolute value of A is greater than 1, this is what's going to happen, vertical stretch. Okay. And then finally, we do have this other transformation here with the +1. Let me talk to Daniel. Can you share with me what impact did the +1 have?
The +1 made it go up on the graph.
Exactly. It made it go up by 1, right? And we know it wasn't consistently because if it only went up by 1, it would have had another dot here. But because it also stretched, made it a little thinner. So that was the other transformation. Number 1, that it had a vertical stretch by a factor of 2. And number 2, that there was a translation up by 1 unit. Okay. Oh, okay. Thank you, Elijah. Any questions on this? Okay. So if it's a fraction, if it's a decimal less than 1, the absolute value, then we know it's going to compress and push down. Little number, it pushes it down, right? If the number is bigger than 1, it's a big number, it's going to stretch it out, okay? Let's go with 5A. We're going to describe the impact here that is related to the graph. All right, so the one thing that is unique, because we've been looking at only the absolute value, is that we have a negative up front. Any guesses how that might change it? Any guesses? Gabriel, what do you think? What do you think the impact of that's going to be? Not sure. Anybody have any guesses? Yeah, what's your guess? Do you think it's going to flip? Yeah? All right. So these are basically the same equation, right? But one has a negative. So let's see what happens. There's your first one. There's your second one, right? Same exact parabola. It just flips it over the x-axis. So when there's a negative, and then let's see what that's officially called. Let me go over here. Okay, reflection, okay? So we want to say, sorry, go over here. That negative right there will cause the reflection over the x-axis. Okay. There's another part of this, the 3. And then there's another number here, +1. Okay. So right here, I have the absolute value of 3 is just, I'm sorry, the absolute value of -3 is 3. This is our value for A. Okay. And since the number is greater than 1, according to my notes, what's going to happen? Is it compression? Is it going to get short and wide? Or is it stretch and it's going to get tall and thin? Stretch. Good. So I'm expecting kind of something more skinny, right? So I'm going to go ahead and I'm going to put here, this is called vertical stretch. Good. Good, Lorenzo. If you wanted to get really fancy, you could say by a factor of 3. And then finally, the +1. That's just a translation up by 1 unit. Easy enough, hopefully. Okay, so we just got to look at each one of those parts, right? This was the value for K, and this here is just the negative in front. All right, so keep that in mind. The negative up front controls whether or not it's reflected, okay? This one has no negative in front, so it will not be reflected. And so when we do this, if I draw my parent quadratic, I'm going to start off 1, 1, and 2 times 2 is 4, so it's going to be up here. Symmetry. This is my original 1. And we know that it's going to, let's see, go ahead and put it in here. I'm going to declare, and I'm going to put in negative 3x squared plus 1. I got my table. Table is honestly easier sometimes than trying to like look at the graph and figure it out. So I'm going to look at negative 2. I got negative 11. That's too big. Negative 1, negative 2. I can handle that. Negative 1, negative 2. I've got 0, 1. And I've got 1, negative 2. And I get an idea about what my parabola is. So did it flip? Did it reflect? Yes, it did. Did it get more narrow? Yes. And did the vertex translate up by 1 unit? Yes, it did. And the best way to check for translation is to compare the vertices, okay? So compare this vertex to this vertex right here. Any questions so far? All right, guys. So let's go ahead. I'm going to go ahead and pause this real quick. I want you to write down the predictions. What do you think? What transformations are going to happen here? Okay. All right, ladies and gentlemen, so 5B, that is vertical compression because of 1/5 being less than 1, and translating down by 7 units because of the negative 7. Drawing is not totally accurate. This graph right here is a better picture if you want accurate. All right, let's look at example 6. So which is an equation for the function shown in the graph? Okay, let's go ahead and let's look at some key points right here. One of them being the vertex. This point right here is 0, 2. So based just on that alone, and remember we have, let's see, we have, what do you kind of expect to see in our final equation? When we're looking at y equals a times x minus h to the power of 2 plus k, what value can we pull from the vertex? Any ideas? Oh, and this is negative 2, my bad. K, absolutely. This right here tells us we're starting because our parent quadratic was always right here, right? Parent quadratic's like this with 1, 1, and then we got the 4. And so we can compare the vertex and automatically tell if we translate it up, down, left, or right, right? So if we look at that, we got 1, 2, we know it went down 2, so we're probably looking at a minus 2 right here. K will have a value of minus 2. Okay, now I want to actually, what are the 2 variables that we always leave in an equation anytime we're writing an equation? Ideas? X and Y. So what we need to do is find everything else out and solve, yes? All right, so when we do this, let's see how I did this before. One of the things we can do is we can pull a point, and we need 3 lines to intersect before we can pick a point. Who can pick a good point on this blue parabola? What's a good point? You can put it in the chat if you like. You need 3 lines, a horizontal, a vertical, and the blue line to all touch at the same exact point. It needs to be a bullseye point. Any ideas? I know what you mean. You mean because this is 1 and 3, right? But you mean like 3 and 1, right? 1, 2, 3, and 1. Yes, perfect. That's a good point right there. Okay. And if we have that point, that's X and that's Y, right? And so I can kind of plug stuff in. Now, when we look at the vertex, we also know if it shifted left or right. Yes? Did it shift left or right? See, here's the original vertex, and here's the purple one. We know that it moved down 2. Did the purple dot move to the right or to the left? No. So we also know a value for h. What's h going to be? 0. So I got that so far, right? Now we actually know what x is going to be because we have 3, right? And what I'm doing is I know everything except for a. So I'm going to solve for a. And I'm going to leave a as my variable in, and I'm going to use my y value right here. And I'm going to solve for a. So we end up with, I'm going to do what's inside the parentheses first, according to PEMDAS. 3 minus 0 is just 3. It's the power of 2. According to PEMDAS, we do the exponents next. 3 squared is just 9. And is it okay if I write it in front of the a? Yes. I'm going to add to my additive inverse. I get 3 equals 9 over a. And then finally, to get a all by itself, I just have to divide by 9. And if I reduce this down, a will equal, if I divide by, actually it works better the other way. But if I divide both the numerator and the divider, the numerator and the denominator by 3, I get, what is my fraction? 1/3, right? That's what you meant. 1 over 3. So now we know what a is, right? We can write our equation. Y is equal to, because we like to leave the y, we've got 1/3. We have x minus 0 squared plus, and oh, that's a -2. So we're going to clean it up just a little bit, right? I don't really need the 0. X minus 0 is just x. So that's actually x squared. And a positive times a negative is a negative. And so either way, you might see it like this or like that. Any questions? Okay. So that's how we write an equation given this. So the main thing I would look at is know that your vertex here, if it went down by 2, right? So we know this was k, right? And if it was at +1, so this value right here is h. So kind of keep that in mind. It tells you 2 different movements. It tells you your horizontal movement, and it tells you your vertical movement. Any questions on that? All right, so let's go over here. I'm going to show you how to do one more, and your practice will be posted tomorrow. We're going to write a quadratic function in vertex and standard form, which contains these 2 points, right? It's very specific that it says the vertex is actually equal to this. So we know we can label this as not only x, y, but it is actually h, k. It's the vertex, so it tells us how it's going to move, right? It tells us that we're going to move probably to the left by -2, and that we're going to move up by 5, okay? And this is just a generic point, so I'm going to label it x, y. We're going to go ahead and write it out. Y equals a times x minus h to the power of 2 plus k. I'm going to write out my skeleton, especially when I got negatives. It's always good to do a skeleton. So I'm going to be popping in a y, and I'm leaving everything that I'm not going to replace. I'm not going to replace the a yet. I am going to replace the x. I have a minus. I'm going to replace the h, and then plus, and I am going to replace the k. So let me go in there and replace everything. I've got y is 1. X is -4. And h is -2. K is 5. Any questions on how I set this up? Okay. So we're still following PEMDAS, guys, which means that we look inside the parentheses first, right? And so that's going to be a negative times a negative is a positive. You could put the whole thing in your calculator if you wanted to, that little chunk, as long as it doesn't have a variable. And we have -4 plus 2, which is just -2. I will warn you though, Make sure that in your calculator that you do not ever do this, -2 squared, because it will just straight up lie to you. You need to make sure you put your negative bases in parentheses because it is actually 4, positive 4, okay? So make sure that you're smarter than the calculator. And we end up with a times 4 plus 5, which I can rewrite this as 1 equals, I'm going to go ahead and take that, 4a plus 5. I'm going to subtract 5 from both sides. This is just simply solving for a variable. There's my 0, right? And I've got 1 minus 5, that's -4. And last, we divide by 4, and a will equal -1. Yes. Any questions on how I did that? Ladies and gentlemen, our final answer will have x and y remaining in it. So a was -1. X will remain in there minus -2 squared plus k was 5. We can clean it up just a little. Negative x plus 2 squared plus 5. Any questions on this? All right, thank you so much for spending time with me today. If you have any questions, stick around. Other than that, you have a fabulous day. Take care. Let's see. No questions here? Today's assignment based on yesterday should be, it was easy. I think it was really easy. So it'd be a good time to just knock it out.